Hey guys, here we are, Chapter 14, Section 4. We're going to talk about using mineral resources more sustainably. Fairly quick one today because there's only so many things we can actually do. Now, really short and quick, the methods for more sustainable mineral use come down to this. We can try and find substitute. Will something else do it? We can reduce the resource waste. Just cut down waste of it. Make sure we count it all as being precious, and we can recycle and reuse these particular minerals. If our cell phones shouldn't be going into the trash, they should be being recycled so we can pull these rare earth metals back out and reuse them again and again. That's kind of it in short. Let's break some of these down. Now, we talk about finding substitutes. We're trying, like I say, we use copper for wiring, right? This is how we conduct our electricity, large scale, power lines, even in a computer, cords that we use at the house, extension cords, etc. We're all basically using copper wire. Well, what do? We need to have something else that conducts electricity. Well, one of the things that we're using is silicon. Now, silicon is largely like what we find around silicates. Sand is a very, very common element on the planet. And silicon is replacing some metals for common uses because silicon can be very strong. Also, silicon, we use it as a semiconductor. It can conduct electricity under certain conditions. So we're using silicon in places we didn't used to use it before. Once again, it's a lot more abundant, easier to get. Technology can help improve it. Along with technologies, we just get new technologies. Nanotechnology is a fairly new field, been around 10, maybe 15 years or so. But nanotechnology allows us to manipulate atoms down at the molecular level and join them into particular shapes. So by using nanotechnology, we have made some really high strength plastics. Along with that is graphene and phosphorine. Now we're going to look at graphene and phosphorine in a little more detail coming up, but these are some new technologies that have amazing potential. Now, substitution just doesn't always work. We kind of have this materials revolution, finding different ways to use certain materials. But for instance, like platinum, this is an industrial catalyst. It's used in a lot of various processes to help things, and we haven't found anything that really does it like platinum. So sometimes substitution doesn't work, and we've just got to be very careful with those materials because once they're gone, and we just have to reuse and recycle. It's all we're left with. Now, I told you we talk about the graphene and phosphorine. Let's talk about graphene. Now, along with technology and nanotechnology, we have learned how to be able to make things very, very small. Now, graphene is just a single layer of carbon atoms. Single layer, very teeny tiny. The single layer of carbon atoms, but it's in a hexagonal lattice. Think like chicken wire. It's in that hexagonal six-shaped lattice. And this particular structure, this one single layer of carbon atoms, but in this hexagonal lattice, throw a picture of it up here, makes it one of the thinnest as well as one of the strongest materials on the planet. And it's an even better conductor of electricity than copper. So this invention, this discovery, if you will, of graphene, where we're beginning to manipulate things at the molecular level, has a whole host and world of possibilities. Once again, carbon is incredibly common, one of the more common elements on the planet, so we're not really in danger of running out. Another one is phosphorine. It's the same thing. Graphene, we talk graphite, comes from carbon. Phosphorine comes from phosphorus. Once again, a fairly common element. And it's the same thing. We're making this very thin, just atoms thick phosphorine, and it is actually more efficient than silicon as well as a semiconductor. So once again, something that we can switch to use in computers, electronics, smartphones, what have you. But these new technologies are bringing along a whole host of possibilities of new materials that could replace others. Sometimes we need to replace them because we're running out. Sometimes we can replace them because they're cheaper and just better. This nanotechnology is a great field to go into because it is wide open right now with possibilities. Now, no matter what, when we're talking about minerals that we're all pulling up out of the ground, we've got to recycle and reuse. They are non-renewable resources. We have to treat them carefully. The cycle is way too long. Water is a renewable resource, comes back very quickly. Oxygen, renewable resource, comes back very quickly. Most of our food sources, renewable resources, they come back very quickly. But these minerals, part of the rock cycle, they do not come back quickly. Also, we lower the environmental impact when we're mining less. Obviously, if I already have an aluminum can, it takes a lot less energy to turn this 100% aluminum can back into an aluminum rod that I might use in a car, as opposed to digging it out of the ground, refining it, smelting it, getting it back into the shape. When we already have the aluminum, steel, what have you, we need to recycle it, we need to reuse it instead of pitching it and it sitting out in a junkyard forever. They need to get back into the system and cycle reusing. We can actually extract valuable minerals a lot of times from this electronic waste. In your cell phone, there's gold, there's copper, there's all kinds of various metals, precious metals, rare earth metals that we need desperately. So when it comes to a lot of things like your electronics, don't just, if you hang on to it, sure, but when you're ready, don't throw it in the trash. Take it back to Best Buy. Lots of these places will take them back. The Apple stores themselves will take them back so they can be recycled. Make sure you get them to a recycling center so they don't find their way in a garbage can, because literally in a lot of these dumps throughout third world countries, we have kids and people going rummaging to try and find them so they can resell them. I mean, it's good that they're pulling them out, but we should just recycle it from the get-go. Also, we need to find substitutes that don't have the heavy environmental impacts. A lot of our early rechargeable batteries were nickel metal hydride. These were particularly bad for the environment, the mining it and also the disposal of them. Switching to batteries we make out of the lanthanide series and even into more currently the lithium batteries. These are much better for the environment and they don't have as bad of an environmental impact even when it comes to the disposal. So sometimes we have to look at both, what does it take to get it out and what are we doing to the environment and what happens when we actually ultimately have to get rid of them. So some of these solutions, in a sense, what can I do? Some of it needs to be at the government level, big industry, but a lot of things you and I can. Once again, reuse and recycle. You have something, use it as long as you can. Don't buy something brand new all the time and go through as much. We're having to create and use more. Use it for its lifespan. Not everything lasts for 20 years. Some things are only good for a year or two. But when you're done with it, recycle it if at all possible. Some things can be recycled, some things can't. Let's just make sure we're recycling effectively what we can. We need to redesign our manufacturing processes to use less mineral resources. As some of you guys get out there and get into jobs and businesses and CEOs and engineers and designers, well, look at that. How can we use fewer resources? Can we pare down? Can we be more efficient? Can we be more cost effective? And can we have a less harmful impact on the world and the environment out there? Sometimes just redesigning our process can actually do it. Just because we've always done it that way doesn't mean it's the best way to do it. Sometimes it takes a fresh set of eyes to see that and make the change. We need to reduce some of these mining subsidies. So the subsidies are being paid. So we don't need to just stop paying the subsidies, But we need to reduce the subsidies for mining, where we're paying the people to mine, and we need to increase the subsidies for reusing and recycling and finding the substitutes. Instead of paying the mining companies their taxes and giving all these breaks, we need to pay for the real price of whatever the metal is. They're going to find better ways to do it if they don't have subsidies just covering a lot of their costs. And we need to turn those subsidies around and pay them towards companies who are doing more in the way of reuse. The companies who are actually, if you have a higher rate of recycling, you get a benefit for it, and companies that are finding substitutes. We need to fund some of these companies who are doing research to find the substitutes. Once we find the substitutes, they can pay for themselves. But a lot of times research and development can be pretty pricey, and sometimes as a government or as a company, we have to look at and invest in these for our future. Guys, that is it. Fairly short one for this round, which is always nice, right? Well, come back next time and we'll look at geological hazards. Take care.